As the big data age approaches, data backup and data analysis are becoming the major concerns of enterprise. In real-world application, customers need to use duplicates of production data for data backup, testing, or analysis. The HUAWEI OceanStor Enterprise Unified Storage Systems incorporate clone technology to address these scenarios. Clone, a type of snapshot technology, obtains fully populated point-in-time copies of source data. Clone is a backup approach that allows incremental synchronization. In a clone, the LUN that stores production data is called the primary LUN, and the LUNs that each store a copy of the data on the primary LUN are called secondary LUNs. After a clone is created for a LUN, an initial synchronization is triggered to copy all data from the primary LUN to secondary LUNs and establish mirroring relationships between the primary and secondary LUNs. The mirroring relationship is called pair. Each clone has only one primary LUN, but can have multiple secondary LUNs. The primary LUN and a secondary LUN form a pair. Each time a secondary LUN is added to a clone, a new pair is formed. After initial synchronization is complete, the storage system executes dual write, which writes IOs synchronously to the primary and secondary LUNs to ensure data consistency between the primary and secondary LUNs. To obtain an available copy of data on the primary LUN at a point in time, you can split a pair. Splitting stops dual write between the primary and secondary LUNs. After a pair is split, write IOs to the primary LUN will no longer be written to the secondary LUN. Data on the secondary LUN is an available copy of data on the primary LUN at the split point in time. You can split the pairs of multiple clones in a storage system simultaneously to obtain copies of data on multiple primary LUNs at the same split point in time. Consistent splitting not only saves time, but also retains the relationship between data copies and database scenarios. What's noteworthy is that pairs in consistent splitting must be from different clones, and each clone can have only one pair engaged in consistent splitting. After splitting, secondary LUNs can be used in data backup or mapped to other hosts so that those hosts can read or write data consistent with that on the primary LUN at the split point in time, without compromising primary LUN performance. After splitting, data changes that occur in the primary and secondary LUNs will be recorded in a DCL. You can synchronize data again from a primary LUN to a split secondary LUN. The storage system copies only changed data from the primary to the secondary LUN based on data changes recorded in the DCL, greatly improving synchronization efficiency. After synchronization, dual write is resumed between the primary and secondary LUNs. Clone not only creates a point-in-time copy of the primary LUN, but also provides a mechanism for storing data on the primary LUN. If data on the primary LUN is damaged after splitting, you can reversely synchronize data from the secondary LUN to the primary LUN to restore data on the primary LUN at the split point in time. Reverse synchronization also uses incremental copy. After reverse synchronization is complete, the pair used for reverse synchronization remains in the split state.